Hello everyone, I'm Dr. Jolsna and welcome to my channel Prostho Hub. So this is the second part of our question paper solving out session and we are discussing the final year BDS part 2 degree exam of Kuhas University of May 2021. And we are focusing on the short note section and we have completed the indirect retainer in our part 1 and the next topic to be discussed is the pyre abutment. So before starting this session, I request everyone to please do like and share my videos if you are finding them useful. And if you have any queries, suggestions, any topic that needs to be discussed, do comment below the video or you can mail me at this mail ID. So let's start. Coming to the contents that you can include in your pyre abutment topic, first the GPT-9 definition, and then we know that a pyre abutment is a special type of abutment where there is much more stress concentration compared to that of the normal abutment. So prosthetic management of pyre abutment is important, and under that you can include the non-rigid connectors, their design, mechanism of action, various other indications and contraindications of NRC, and the different types of non-rigid connectors. So, by definition, pyre abutment, also called as the intermediate abutment, is a natural tooth located between the terminal abutments that serve to support a fixed or a removable dental processes. So, the most common clinical situation that you can see is of a missing first premolar and a missing first molar with the second premolar acting as the abutment for both these edentulous spaces. So there is a free lone standing abutment with adjacent edentulous spaces on either side, and such abutments are called as pyre abutments. Coming to prosthetic management of a pyre abutment case. So usually rigid connectors are the preferred way of fabrication of a fixed dental processes because the connectors are rigid and this rigidity provides desirable strength and stability to the prosthesis while minimizing the stresses associated with the restoration. But completely rigid restoration is not indicated for a pyre abutment case. This is because of the physiologic tooth movement, the arch position of the abutment, and the disparity in the retentive capacity of the retainers. So let us see them in detail. Now in a pyre abutment case, because of the curvature of the arch, the buccolingual movement of an anterior tooth occurs at a considerable angle to the buccolingual movement of a molar. So when these forces and movements are directed in different direction on the anterior and the molar, they can create stress around the abutment as well as between the abutment preparation and their respective retainers. So earlier it was theorized that the forces are transmitted to the terminal retainers as a result of the middle abutment, that's a pyre abutment, acting as the fulcrum which causes failure. So here in the picture you can see when there is a load on one end, the other end tends to lift up with the pyre abutment acting as the fulcrum. This was the earlier concept. But later photoelectric analysis, stress analysis and displacement measurement studies indicated that prosthesis is actually bending rather than rocking. And also further studies showed that it is the tension between the terminal retainers and their respective abutments that is causing failure, and it is not the pyre abutment acting as the fulcrum. Also when there is extra stress on loading, there is intrusion of the abutment, and that can also lead to failure between the retainer and the respective abutment, and all these can result in the cast getting loosened, and that will result in marginal leakage and further caries extension leading to prosthesis failure. So when there is debonding that is happening, it is usually happening on the retainer which is less retentive, that is usually the anterior teeth because it is generally of smaller dimension, it is usually a canine. So the retention on a smaller anterior teeth is usually less than that of a posterior tooth. So debonding happens on the less retentive terminal retainer, that is usually the anterior teeth. So there are limits to increase a retainer's capacity to withstand the displacing forces. So some other means must be used in order to neutralize the effect of these harmful forces. So the use of a non-rigid connector has been recommended. So let us see the non-rigid connector in detail. A non-rigid connector functions as a stress breaker between the retainer and the Pontic, and the movement within the non-rigid connector is enough to impede the transfer of stress from the segment where the load is happening to the rest of the FPD. And there are various types of non-rigid connector. Among them, the most common one is that which comprises of a T-shaped key, which is also called as the male component or the patrix or the tenon, which is attached to the Pontic, and a dovetail keyway, that is the female component, the matrix or the mortise, which is placed within the retainer. So the male component is on the Pontic and the female component is on the retainer. Now let's see how the NRC or the non-rigid connector acts as a stress breaker. So the non-rigid connector transfers the shear stress to the supporting bone rather than concentrating them into the connectors, and it also helps the abutments to move independent of each other. Thereby it minimizes the mesiodistal torquing of the abutments. And we have also said that the buccolingual movement of the anterior is at a considerable angle to the buccolingual movement of the molars. So these forces and these movements are in different directions, which result in stress. So the non-rigid connector compensates for this difference in the resistance and retention form between the abutments. And the design and passive fit of the non-rigid connector is important for the long-term success of a long span FDP. So the NRC should be passive fit. So here you can see that this is the key, which is the male component attached to the Pontic, and this is the keyway, the female component, which is attached to the retainer. Now let us see the design of the most commonly used non-rigid connector, that is the tenon mortise or the keyway one. So here we know that the female component or the mortise is prepared within the contours of the retainer, and the tenon or the male component is attached to the Pontic. So according to Schillingberg, the location of the stress breaking device in a 5-unit pier abutment restoration is usually on the middle abutment, that is the pier abutment. This is because placing the stress breaking on either of the terminal abutment can result in Pontic acting as a lever arm. So the ideal location of the stress breaking device is on the middle abutment. Now coming to the key and keyway. The ideal location of the keyway is on the distal aspect of the pier abutment. So the distal aspect of the pier abutment, this is the ideal location of the keyway, and the key is usually placed on the mesial aspect of the distal Pontic. Now why this? This is because the posterior teeth tends to show a slight mesial movement under the vertically applied occlusal forces. So when this happens, around 98% of the posterior teeth tilt mesially. So when this mesial movement happens, the keyway of the connector is placed on the distal side of the pier abutment. So the mesial movement seats the key into the keyway more solidly. So there is accurate placement of the key into the keyway when mesial shifting happens. So there is slight mesial movement. If it is placed on the mesial side of the Pontic, so if the keyway is placed on the mesial side, what happens? This will result in key getting unseated during the mesial movement of the posterior teeth, and this can produce a pathologic mobility for the anterior retainer, that is the canine, and can cause failure. So this is why the keyway is placed on the distal aspect of the pier abutment and key is placed on the mesial aspect of the distal Pontic. Coming to the other indications of non-rigid connector, so NRCs are used when there is different paths of placement for the abutment, that is when a single path of insertion cannot be achieved in case of a non-parallel abutment. It is also indicated in large complex FPDs and in pier abutment, which we have already seen, and also in misaligned abutments. Next, the contraindications. So when abutment teeth exhibit significant mobility, processes with non-rigid connectors should not be used. So there must be equal distribution of occlusal forces on all parts of the FPD. And when the posterior abutment opposes an edentulous space or an RPD also, you cannot use a non-rigid connector. This is because the posterior abutment can supra-erupt, and supra-eruption of the abutment leads to misfit of the key and the keyway. So when the posterior most teeth supra-erupts, if it is opposing an edentulous space on an RPD, this will unseat the key and keyway. So these are the contraindications of non-rigid connectors. Next is the different types of non-rigid connector. You can just mention the different types in your answer. So the first one is the tenon mortise or the dovetail or the key keyway, which we have already discussed about the design and purpose. Next one is the split Pontic. So this is entirely within the Pontic. So the Pontic is actually split into mesial and distal segments, and this is useful in tilted abutments. So in tilted abutment, the use of a conventional dovetail will need the preparation of a very drastic box in the distal aspect of the pyre abutment. So in such cases, you can go for a split Pontic, and here actually the Pontic, the processes consist of a mesial retainer, the Pontic and the pyre abutment retainer with a distal arm. So this distal arm, this is the key, and the keyway will be placed on the Pontic of the distal retainer. Finally, the cross pin and wing connector. So this is a two-piece Pontic system that allows the two segments to be rigidly fixed after the retainers have been cemented on their respective abutment preparation. So these are also similar to the split Pontic connector. So the Pontic is actually split, and it has got two parts. One is the distal retainer and wing. So this is the distal retainer with the wing, and the next part is the retainer Pontic segment. This is the retainer Pontic segment. So after fabricating the retainer wing and retainer Pontic component, they are aligned on a working cast, and a 0.7 mm pin hole is drilled across the wing and Pontic using a twist drill. So the first cementation is the distal retainer and the wing, and the next the retainer Pontic segment is cemented, and then the tapered pin is actually seated into the hole using a punch and mallet. So this is the completed cross pin and wing fixed partial denture. So this is also used in case of tilted abutment. So let us have a recap of our topic pyre abutment. So first we have defined what is a pyre abutment, the GPT 9 definition, and then the prosthetic management, which included the non-rigid connectors, their design, mechanism of action, indications and contraindications, and the various types, that is the tenon mortise, the split Pontic, and the cross pin and wing connectors. So here comes the end of our current session. Thank you all for watching my video, and please do like and share my videos if you are finding them useful. If you are new to this channel Prostho Hub, please do subscribe and show your support. If you have any queries, any topic that needs to be discussed, do comment below the video, or you can mail me at this mail ID. So bye from Prostho Hub until our next session.